times in training. Here you can see that vent. It has a T shape to prevent any change in attitude of the space station during venting. From there, the final task of EVA-2 will be to install a gap spanner. This is a translational aid that helps the crew translate around the ammonia jumpers that they just installed. This is also the same tool that they've been using to hold the ammonia jumpers and thermal blanket in place. That completes EVA-2. Bob and Nick will clean up their work sites and head back into the joint airlock. They'll have 2 days before their third and final EVA. Before we start talking about EVA-3, I'd like to introduce you to a piece of hardware that you'll probably see a lot of on EVA-2. This is a fluid quick disconnect. At the end of each of the ammonia jumpers, you'll find one of these, and on the lab in Node 3, you'll find the other end, the other mating end of that. What the crew is going to do when they're ready to attach the jumpers, they'll make sure that they have good alignment with both halves. They'll mate it, and they'll verify that the forward band is visible. This is an indication that they have a good mate. They'll also do what we call a snapback test. When they pull back on this ring, they'll make sure that the forward band is visible again. What this does, it defeats one of the known failure modes for this mechanism. Finally, they'll perform a pull test to make sure that everything is secure. And once they get the go from the ground, they'll then open up the bail. This will allow flow of ammonia from the module into the jumpers. So they'll depress what we call the detent button, which will allow them to move the bail forward. Once the bail is fully forward, they'll notice that the detent button pops up, and we call the aft white band will now be visible. This is an indication that you do have a good opening and a good flow path for the ammonia to flow through. The crew will then rotate the locking collar so that the detent button cannot be inadvertently depressed. With that, we'll roll the video for EVA-3. The first task on EVA-3 will be for Bob to connect fluid QDs like we see here, or fluid quick disconnects. Bob and Nick will both start out outside the joint airlock once again, and they'll translate down to their work site. Bob will revisit the ammonia jumper work site. So Bob will be opening up the redundant loop, or the second loop for ammonia. This is what we refer to as loop B. We want to make sure that everything goes according to plan when we open up loop A on EVA-2 before opening up the second loop on EVA-3. Once Bob throws all 4 bails on the fluid quick disconnects, we'll have 2 redundant systems. He'll close up the thermal blankets, and then he'll disconnect one of the heater cables that Nick connected during EVA-1. Now that Node 3 is activated, this is no longer required. He can now reconnect to airlock shell heater power, where we temporarily borrowed power from on EVA-1. While Bob is performing this task, Nick will be connecting some heater cables for the pressurized mating adapter number 3. Between EVAs 2 and 3, a cupola was relocated to the nadir port on Node 3, and PMA number 3 was relocated to the port end cone of Node 3. Nick will be mating these heater cables so that PMA 3 can be used for stowage. He'll have a series of bolts that he needs to release in order to free that cable, and then he'll be borrowing power from Node 3. From there, Bob and Nick will both translate down to the final home of the cupola and remove a thermal blanket that's no longer required after the cupola has been relocated. You can see this is a fairly large thermal blanket. It does come apart in 2 pieces. They'll remove one half at a time. There's actually a portion of the blanket that covers each window shutter on cupola. Here you can see Bob rolling up one of those covers. Once they get all 6 of those covers rolled up, they'll then remove one half of the blanket, fold it up, and stow it into an EVA bag. Although it may not look like it, dealing with these thermal blankets is one of the more taxing and hand-fatiguing tasks, but again, Bob and Nick have worked hard to develop a technique that works very well. Here you can see him putting the finishing touches on getting that blanket into the bag. Nick will then release launch restraints on the window shutters. These launch restraints were put in place to protect for launch loads, but need to be removed in order for the cupola shutters to be open for viewing. There's 3 bolts on each of the 7 shutters. While Nick is doing that, Bob will be installing on-orbit installed worksite interfaces, or WIFs. These are sites where crew members can install portable foot restraints if needed for specific EVA tasks. So here you can see the location for each of those 3 WIFs, or worksite interfaces. Bob will also be installing some more handrails. These handrails, again, could not be installed because they interfered with the payload bay envelope. There you can see 4 of the handrails that Bob is going to install. Here's the 5th handrail. Each handrail is secured in place with 2 EVA bolts. Once both bolts are driven to the appropriate torque, the crew members are then allowed to translate onto these handrails. Here you can see the 6th and final location for the handrail that Bob's going to install. Once the handrail installation is complete, Bob will head back down to the ammonia jumpers and take some closeout photos to verify that we have enough clearance for the new module that's going to be arriving on the final shuttle mission. After that, Bob and Nick will meet up on Node 1 port. They'll route a fiber optics video cable that's going to run from S0 over to the Russian segment, which will eventually be the home of a new base for the space station arm. This cable will provide video to the arm when it's at that base. See that we have a rather lengthy cable. Bob is going to be connecting his end to S0. He'll actually make the connections. And here in this video, you can see him using what we call a wire tie to secure the cable in place. And he's working here in an area we call the rat's nest because of all the cables that already exist in this area. From there, Bob and Nick will move to their final task. This task is actually what we call a get-ahead that will only be performed if we have sufficient time at the end of this EVA. They'll head up to the flex hose rotary coupler, and they'll release a series of clamps that we call P-clamps because of their shape. If this component ever has to be changed out in the future, releasing these clamps will save a significant amount of EVA time. Here you can see one of the clamps that the crew members will release. Nick will be working on the starboard side, and Bob will be working on the port side. From there, both crew members will start to clean up their work site. They'll head back in to the station via the U.S. joint airlock, and that will complete their 3rd and final EVA. And that was all that I had for today. I'd like to turn things back over to Brandy.
Okay, we'll start with questions here in the room and then see if there are any out at other centers.
Bill Harley with CBS. How long is that fiber optic cable that's running back to the Russian segment?
I'd have to double check that. I think it's around 70 feet, though, is my recollection.